Alright, now we're going to take these and apply them to actual equations. So, using the properties that we just used, especially namely the one-to-one property and inverse property, let's solve these mathematical puzzles. And this is something I stole from Mr. Fay. He called them mathematical puzzles of might. You can call them whatever you want. Anyways, natural log of x equals 3. If we raise both sides, or make both sides an exponent, if we do e to the x equals, e to the natural log of x, goodness gracious, I'm having a hard time talking, equals e to the third, the left side just simplifies to x, that using that inverse property, and then e to the third, well, let's just leave that as e to the third. Let's call that good. Again, that's using the inverse property. Now, if you think about the structure of a natural logarithm, natural log of x is the same as log base e, base e of x equals 3. Now, using what you know about logarithms, if you do e to the third equals x, that's just another way of approaching the same problem. Either way, you get x equals e to the third. Letter B. E to the negative x squared equals e to the negative 3x minus 4. Well, they both have the same base, so we're going to say negative x squared equals negative 3x minus 4. That's a one-to-one property. Now, from there, we're just going to use some algebra. Let's bring everything over to let's actually bring everything over to the right side. So if we add x squared to both sides, we end up with 0 equals x squared minus 3x minus 4. That side is factorable, so we have 0 equals x minus 4 times x plus 1. What solutions of x make that true? That's x equals positive 4 and x equals negative 1. So those are our two solutions. Next page, we got a couple more to do. Flip it over, there we go. Next, we got 3 times 2 to the x equals 42. Let me zoom in on that. So starting us off, we're going to divide both sides by 3. And we got 2 to the x equals 14. Now, we can do a variety of things here. I'm going to take the log of both sides. Actually, I'm going to take the natural log of both sides. Natural log of 2 to the x equals natural log of 14. Now, the reason we do this is using a property we haven't talked about yet today, is that power property. If you have something inside of something inside of a logarithm with an exponent, you can move it out front and we can say x times the natural log of 2 equals natural log of 14. Now, to solve for x, we got to divide both sides. Oop, that was bad. Divide both sides by the natural log of 2. Now that gives us simply x equals natural log of 14 divided by the natural log of 2. Now we have calculators that have the natural log button on it, and when you do that, we end up with 3.81. So natural log of 14 divided by the natural log of 2 gives us 3.81. Next up, natural log of x equals 2. Give this one a shot on your own. Sorry, air server froze for a second. Give this a shot on your own. It's similar to some problems that we've done before. So pause the video. And we're back. So I'm going to do the same thing. I'm going to raise to the both sides. So e to the natural log of x equals e to the 2. So the left side simplifies to just x. The right side just simplifies to e squared. So we got x equals e squared. And again, if you want to think about it as natural log of x equals 2, and again, that's log base e of x equals 2, then using what we know about logarithms, e squared equals x. Same thing that we did on the left side. Next up, log base 3 of 5x minus 1 equals log base 3 of x plus 7. Well, using the one-to-one property, 5x minus 1 equals x plus 7. To solve for x, we want to get all the x's on one side, so I'm going to subtract x from both sides here. And I'm also going to add 1 to both sides. So we end up with 4x equals, when I add 1 to both sides, I get 8 over here. To solve for x, I'm just going to use some good old algebra skills, divide both sides by 4, we end up with x equals 2. And the last one, log base 6 of 3x plus 14 minus log base 6 of 5 equals log base 6 of 2x. That left side, we're going to have to use a property we haven't talked about today. That quotient property. If you have one log minus another, we can combine them into one single log. So we have log base 6 of the first one, 3x plus 14 divided by 5. So it's the log base, the numerator comes from that first logarithm, the denominator comes from the second, equals log base 6 of 2x. Now to solve both sides, well, actually I'm getting a little ahead of myself. Now we have log base 6 on one side and log base 6 on the other. So we end up just using the one-to-one property and saying 3x plus 14 divided by 5 equals 2x. Now to start solving for x, let's get rid of that fraction. So let's multiply both sides by 5. We have 3x plus 14 equals 10x. Now to solve for x, let's get all the x's on one side. Let's subtract 3x from both sides. We end up with 14 equals 7x. My brain froze there for a second. To solve for x, we got to get rid of that 7, so let's divide both sides by 7, and we end up with x equals 2. So again, we just used the one-to-one property a couple different ways.